ontology. Here's an example with disease where you have lots of different ways of describing the same concept. So here we've got dyschromatopsia, which could be considered known as color blindness, and we've got a whole myriad of terms that will describe this concept. And this can cause us real problems with data integration and search. So you imagine a search over the literature for something like color blindness, and we can see if we search for exact match for color blindness in PubMed, we get around 647 results. If I search for dichromatopsia, we've got 270 results, and it's not clear if there's what the overlap is there. And if we want to search for something more generic, like abnormalities of the eye, we actually get no direct hits for that. So you can imagine how this is just a general problem for dealing with integrating data when it's the same data but described in different ways. And the kind of solution that we have for this is to kind of build standards for terminology, so moving away from text to actual accessions to represent these concepts. And in this example here, I'm showing a kind of crude ontology of color blindness that we might build, and we can assign IDs to the concepts and then start to think about how these concepts are related. So we can build trees, we can talk about dichromatopsia being a subclass of abnormality of vision, and there's other kinds of relationships, so we can say that it's got some disease location that might be in the eye. And we also attach additional sort of metadata to these terms, so we've got capture all the kind of synonyms, a sort of human readable description for this term. So this is essentially what we do in building ontologies. And with these ontologies then, we've got the task of how we actually start annotating the data with the ontologies. So here's some experimental data taken out of the Array Express database showing some samples. And typically what we'll do is we'll look at the free text descriptions and start to annotate these with ontology terms. So start to add some structure and semantics to this free text. And this adds value to the data. So once we've actually started marking up the data with ontologies, we can start to build smarter applications. So primarily we can build search applications. We can do things like query expansion to help find data discovery. We can do lots of data analysis using the ontologies. So gene set enrichment analysis with gene ontology terms is a good example of that. We've got lots of examples at the EBI of data integration platforms and generation of nice visualizations that are actually driven by the fact that we can handle on this terminology. So the CTTV is a nice example platform where you can see these kind of visualizations driven by the ontology, and something like the GWAS catalog as well, which is heavily annotated with ontology terms, and these terms are really used to drive the kind of visualizations of the data. So we've been very busy over the last, say, 10, 15 years in building ontologies for the life sciences. So there's a whole spectrum now of ontologies available, ranging right down from genotype to phenotype. And this kind of slide is probably several years already out of date, but gives you a good feel for how many different ontologies we have covering the different domains of biology. So with all of that taken in, why provide an ontology lookup service? So given that there's this large number of ontologies, these ontologies can range into sort of size and complexity. These ontologies change regularly. Some are updated daily, monthly, and they can be quite complex to deal with. So they aren't always orthogonal. So we're increasingly seeing how different ontologies are merging with other ontologies, mixing in terms across different ontologies. And essentially, as a developer trying to work with all this, you're going to have to make sense of all this kind of ontology landscape. And really just this kind of wrangling of the ontologies is busy work. It's not interesting science, really. There are still various file format issues around ontologies. There's still some metadata standards that we're trying to establish for ontologies for how we capture common things like descriptions and synonyms. So really the aim of providing something like OLS is to provide a unified access to all these public ontologies that are being developed, and to deliver them back as a service, so that if you're only really interested in sort of accessing these ontologies and doing sort of straightforward queries, term lookup, pulling out children's of terms, you don't have to deal with some of the sort of more lower level technical details of how these ontologies are built and composed. So we primarily want to offer through OLS a search service over these 150 or so ontologies, and then we extend this with services for actually annotating data. So when you've got some data, how do you get from your data to some data that's nicely marked up and annotated with these ontologies? And as I said, the ontologies aren't always orthogonal, and sometimes we have a lot of cross-references across ontologies, so we also want to try and expose that as a service as well. So this is the OLS as it currently looks in its new form. It's had a full rewrite from the original system. The original system was around for, I think, nearly 10 years, so it was probably one of the first ontology repositories that we had in the life sciences. But the code was very out of date, and kind of a lot of things had changed in the last 10 years with the kind of ontology landscape. So it made sense to actually rethink how we build an ontology service at this scale. So we had a redesign from the ground up. Currently, we have around 150 biomedical ontologies. The important thing around that list is that we have a mechanism to ensure that OLS is completely in sync with all the ontologies coming from the ORBL Foundry and the ORBL Library. So we have a new ontology metadata standard, really, that was developed with the ORBL Foundry for describing what ontologies are available and where you can get them from, and OLS uses that every night to check that we've got the latest versions of the ontologies and to pull these versions in so that we were always able to deliver you the latest versions. Primarily, the OLS can be seen as a search engine across these ontologies. We also have visualization components, so these are basically different ways to view the content of these ontologies. The other primary use for the service is through its API, so we provide a powerful REST API, a normal REST API for programmatic access to these ontologies. The other thing is that, like a project that we develop here, this is a fully open source project. It's a really generic infrastructure, so it's designed to be fairly modular. So if you need to work with ontologies at the kind of API level, you can download our infrastructure, load your own ontologies in. If you need our REST API, you can again set up local instances. It's been designed so that it's quite deployable in different environments. And there's a link to the GitHub site there where you can get access to all the code. So, like I said, we have some visualization tools, and I think what I'll do at this stage is I'll just try and switch over, and we'll just have a little walk around the site, and I'll show you some of the key features. So hopefully now I'm presenting my browser. Good. So this is the home page. Here you can see the last time the ontologies were updated. We've got 148 ontologies. This is 4.6 million terms indexed, around 12,000 properties, so these are relationships within those ontologies. And we're also starting to index any individuals captured within those ontologies. So we can put in a basic search. We have a two-type auto-suggest feature on the homepage, so we can show you basically suggestions on what we might think you're looking for, but you can also jump down into individual terms. So you can see that a term like heart, well, it appears in different species ontologies. If you know the ontology that you're looking for, you can jump straight in, or you can jump through to the kind of default search result. This is a fairly exhaustive search, so it goes across pretty much all the fields that we can find in any ontology to find any matches. We've got faceting on the left-hand side, so you can see the set of ontologies where you've hit. You can hover over these to get some more information about the actual ontology. Within the search results, we've done some grouping, so you can see that here the term heart hits the Uberon term, so the primary ontology is the Uberanatomy ontology, but you can also see that this term, this specific term, is used in a whole bunch of other ontologies. So it might give you some indication that this is an important term. We click through then, we get down to the individual term view. From here, you've got the primary, the full URI for the term. We put the description and any synonyms up at the top. And then we have a tree-based visualization that will basically show you both ISA and any partonomy relationships. This is currently a fully expanded tree view. I think that we might in the future think of a way of having a more collapsed summary view. But as you can see, terms now often have multiple classifications in the ontology, and this view really shows you this poly classification that you get. On the right-hand side, we show the metadata about the terms. This is any other information that's provided by the ontology. We've got some comments. We've had the set of cross-references. And then further down, we have actually sort of logical relationships. These are related terms within the same ontology. And we also have the incoming relationships. So what are the terms are actually talking or related to this term heart. With a term like this, I use this as an example because it's a pretty well-connected term. We have an alternate visualization that we've been developing and still are developing, so you can click through to the graph-based visualization. And here we'll show you then for the given term, you can kind of filter on and off the different relationships. So here we've said, okay, we've got heart, it's got 4 parents, I can expand on these. If I'm interested in what develops, terms that develop from the heart, you can start to click them on and sort of navigate the ontology through this graph-based view. I'll go back to the home page then and show a few other things. If you actually just want to browse all the ontologies, we've got an ontologies tab here, so you can actually see the full list and the description of all the ontologies. And you can click through, if we search for something like EFO, we can jump to the EFO ontology, so you get this home page where you can actually just have a generic browse through all of the terms if you want to look at it that way. We've got a stable download link, so this is the download to the file that we pulled in, so this should be a stable URL for getting versions of the ontologies. We can link out to the home page for this ontology and provide contact information. You can also click and browse around the ontology hierarchy from the root terms in this view. One of the new features that we've been working on is to deal with the ontology change. So, like I said, we provide the latest version of these ontologies, but we know that the ontologies change and we have things like terms getting deleted, and we're trying now to track this so that if terms get obsoleted or a term is removed from an ontology, that we would give you some way to find when that term was removed and maybe find a suggestion as to what the replacement or what the new term should be used. So there's this ontology history tab here. If you click on this, here you can see the releases of EFO that we've indexed in OLS, and you can drill down into a particular release and you can get a view. We don't record all the changes, but it's certainly a subset of changes that we currently think are important. So we can see that in this release, there were 650 new classes added. We can see that there was some definitions added, some labels. We can see that some terms were marked as obsolete. So there were 6 obsoleted classes. And you can drill down then into the changes for this particular ontology. So we've got, here's the plant term obsolete. Click through to this and we've extracted the, okay, this is an obsolete plant cell term, and we've got a reason for the obsolescence and a possible consideration for a new term. You have to excuse me because I've got a bit of cold. So the final thing I want to show on the interface is the API for the people who are interested in accessing OLS in that way. So for pretty much any URL that you can get through the interface, you can get to an API endpoint for these where you can get JSON back. So we have a powerful API for doing searching, where you can restrict it to searches across specific fields, pull back any fields that you're interested in. Again, at an individual term level, there's a button up here which will show you how to get to the API, the JSON representation of this term. Here you can get access to all the metadata. And then we have these links to get access to the parent terms, all the ancestral terms, the children, the descendant terms. So you can really navigate the structure of the ontology using this API, and we provide all the links for you to navigate around the structure of the ontology programmatically. So that's all I wanted to say about the interface for now. I'll add backup slides. So I'll talk a little bit about our build process. So like I said, we do a nightly crawl of all the registered ontologies, and then we build 3 main primary indexes which are used to drive the site. So we build a Neo4j index, which is the kind of stores all the graph-based representation of the ontology. We build an Apache Solr index for powering the search, and we're currently working. Oh, sorry, Helen just told me that I'm not sharing my slides with it. Go back to PowerPoint. Okay. So basically we build different indexes to serve different aspects of the application every night. We're currently working on building a Virtuoso index as well, so that we can provide full sort of RDF Sparkle-based access to all the ontologies. And then these indexes are distributed over our various data centers, so we get sort of load balancing. So we should be able to really scale up the delivery of this service across multiple machines. So I'm going to move on to talk a little bit more about the kind of wider application now of OLS and what we're doing with OLS. So one of the primary things that we're interested in is how do we map all this messy and fuzzy data that we get, certainly the experimental data and the description of samples and so on. How do we get this from the kind of fuzzy text form to a structured ontology description? And this is obviously hard for lots of reasons. So like I mentioned at the start, you've got various ways of describing the same concepts. We might have spelling variations, and then there's just kind of errors in typos and all kinds of things that you can imagine that people do, and we see all of these. So we have a kind of sister platform for OLS, which is called Zooma, which is really about exploiting all the curator knowledge. This is effort that's being done at the EBI to annotate data with ontologies. The data that's coming in, we have curators sitting down and actually manually saying, okay, this data maps to this ontology term. And previously, where this data has kind of gotten into the database and been lost, we're trying to pull this and expose this back out through the Zooma system. So the next time we see this kind of common misspelling or this common, error, we know how to fix it in future data. So we can build this kind of repository of curated ontology information, and we want to exploit all the work that our curators are doing so that we focus all our effort on just annotating new unseen data. And data that we've seen before, we don't have to keep going back and annotating it. So this is largely at the moment seeded with the Gene Expression Atlas data, the Array Express data, and the GWAS catalog data, and is unsurprisingly heavily focused towards ontologies that are sort of captured within the experimental factor ontology space. But this is a generic platform, so you can, we can load data, any other kind of data sets in here and any other kind of ontologies, and actually tailor it to different kinds of views of the data. So this is what Zooma looks like at the moment. This is the web interface. Again, there's an API behind all this. It's primarily designed for programmatic access, but you can do a test with some data that you have, put it into Zooma, and you'll get back a ranked set of matched ontology annotations. And you get the provenance as well as to where the match came from. So you can see, if you actually drill down into these results, that these aren't purely lexical matches. You've got things like failure and decondensation mapping to this absence of mitotic chromosome decondensation phenotype. And this is mapped because it's been seen in one of our other databases before, so we can be reasonably confident that this is a good ontology match. So you can see then, with the power of kind of Zooma coupled with OLS, that we're trying to build this kind of pipeline where you can shove in data, raw experimental metadata at least, and put it through this pipeline, through these services that we have, and hopefully at the end you get some kind of structured, explicit knowledge that we can actually query. And we have sort of three primary tools at the moment that are helping us build this pipeline. There was an animation there. No, it's not. Okay. So Zooma and OLS are really there for helping us with the data cleaning and the data mapping to ontologies. A thing that I'm not going to talk about, but you can look up if you're interested, is another tool that we have, which is called Webulus, which is a tool that helps us to build ontologies from templates. So we also have to deal with the gap that there are still terms that we don't have in the ontologies, and Webulus helps us to kind of rapidly build new terms in the ontologies, And this is kind of a feedback system. So the annotation, as Zooma improves and as we get more terms, we get better at doing the data annotation and curation. And if we think about these different components of services, then this really kind of links through then to the work that we're doing now on interoperability services for the CORBEL and Excelerate projects. So both of these projects have an interoperability component, and it's all been driven around this idea of making your data available following the FAIR principles, which is making your data findable, accessible, interoperable, and reusable. A lot of the work that's being done here, it's all use case focused. We're working with the data providers and the data integrators to find this kind of set of services that are required to move from people publishing data to having interoperable data. And like I said, we've already got a lot of metadata-rich resources, especially at the EBI. So these are resources where we've already spent many years working with tools like Zooma and OLS to improve the metadata in these resources. And I think the goal now with CORBEL and Excelerate is to take those services and make them available and see how they adapt to much wider variety of use cases that are coming across all the different European research infrastructures. So you can go and find out more about CORBEL and Excelerate and see some of the use cases that we're working on. There's a brief description on this slide. And what we're really interested in the interoperability component is what are these individual interoperability services that are needed. So OLS, which I've presented, and Zooma form part of a whole suite of tools and services that we're currently developing and trying to map these up with the use cases to find out, okay, which use cases need ontology services or identity services or ontology mapping services. And the way that we're going to sort of be running this process is through these Bring Your Own Data workshops. So there'll be a series of workshops where we get the data generators to come along with the data and put these with the people who are developing these interoperability services and really do this kind of marrying up of data to services for interoperability. So just coming back then to finish with what's coming next for the Ontology Lookup Service. So like I said, the next big thing is to really focus now. Now we have a good platform for dealing with the actual ontologies in their raw form. How do we extend this with extending Zooma to support the full breadth of ontologies in OLS? So we're going to be working heavily on our data annotation pipeline to get to this phase where you can do a reasonably good pass with some data automatically mapping it to existing ontologies. The other thing that we're working on is the ontology mapping service. So this is going to be a new service, again, that will be part of the OLS system. And this is where, certainly in the space of disease, where you have a lot of terminologies, so things that aren't classically ontologies and things that don't fit nicely into an infrastructure like OLS, but are still relevant for how data is being described. So I'm talking about medical terminology such as SNOMED and ICD. How can we expose the cross-references between these kind of medical terminologies that often come with kind of complex license restrictions, and how can we map these to the publicly available ontologies that we have that we're actually annotating a lot of the public data to. Like I said, there's going to be some challenges here about how we get pan-European access to the mappings across these ontologies. And like I say, everything that we are doing in this space over the next few years will be driven by these requirements that we're getting from CORBEL and Excelerate. So that's the end. I want to thank all the guys in the Samples, Phenotypes and Ontologies team who are working on OLS and Zooma and the tooling that we have. We had a lot of input from Matt Pierce from the Flax, who's a search specialist, helping us tune Solar for this for doing ontology type searching, ontology type querying. So there's a project called BioSolar. If you're interested in ontology search, you should go and have a look at. Obviously the various funding projects and the Diachron project, which developed a lot of the ontology change tracking functionality that you can see in OLS, and then previously Biomed Bridges and now the funding from CORBEL. There's some links on this slide. It's the link to the OLS site itself. If you have need any support or have any questions, you can email the OLS support mailing list. We also have an issue tracker on GitHub, so if you have more sort of technical issues or want to report bugs, you can use that. And if you just want to sign up to general announcements to hear about when we're rolling out new features, there's an announcement list for OLS, so I'd recommend you sign up to that if you're interested. And with that, I'm happy to take any questions.